אני מאוד שמח להיות איתכם. I will do the talk in English. Perhaps first, it could be good for me to know you a little more. Is there anyone that doesn't know what is a Lambda, AWS Lambda? Among you? Everyone is aware of it? No, not sure? Okay. Serverless? Okay. Another question, which language you use for AWS Lambda? Java, everyone? Or Java? Okay. Did you try to compile the Java code to native, or is there anyone that has tried? No? It is, okay. It didn't work. Okay, good. You tried? No? Okay, just one, and it was not working. Okay, I hope with my project it will work now. A few information, some facts about me. So I have a big experience with Java from the beginning. I had different roles in company of all size. I'm now freelance with my company, and I'm the creator of microlam.io framework that I will present to you. So the first time I tried to use serverless for my work in companies, the first idea was to look for existing frameworks. And this is exactly what I was looking for. So I don't like Gradle. I want a Maven project for AWS Lambda using the CDK. You know what is the CDK? No one? Okay. So the CDK is something provided by AWS to code your infrastructure. Okay. You can before it was possible to use SAM with a descriptive file, YAML, explaining what is your infrastructure, and to deploy it with this file. Yes, it's using CloudFormation. And now there is something better to use infrastructure as code using the CDK. So CDK is the best you can get for free in this area. There are also products you can use and pay for them, but CDK is free and you can use it. And also, I found very fast that there is a problem with Java, the problem of cold start. I will explain also a little more in the talk what it is. So I needed to compile at that time with GraalVM native image. It's another product from Oracle, and it gives you the ability to compile to native. Okay, you have Java, your Java code you compiled you are compiling to bytecode, and you need a JVM to run it. Okay, with native compilation you don't need a JVM. Directly you run an executable for the platform. And for the cloud you need to compile for Linux, and it is of great help for solving this problem of cold start. And also for reducing costs, because with AWS Lambda, you are paying for the time it is running, for the memory it is used. So if you are reducing the time of the call, you are also earning money. Unfortunately, when I tried Micronaut or Quarkus, I found that there are big frameworks doing everything. So it's not only serverless, it's microservices, you can do everything. Okay, it's great, there are great frameworks. The problem is, it's very difficult to find exactly what I was looking for. Also, I wanted support for a recent version of Java, and it was not easy to find it. So the documentation was outdated. I tried an example, it was not working, as you tried. And also, when I wanted to fix the problem, I found that they are using a plugin inside Maven that is doing everything, and I don't have the code. It's not easy to fix it directly on the project. So I was stuck, and also it was not supported the last version of Java. So nor the CDK at that time. So I decided to do it myself. And now I created microlam. It's a Java micro framework, so something very small, doing a specific task, but I hope doing it well. It's dedicated to AWS Serverless. Okay, it's not doing anything else, just a project for Lambda, targeting simplicity, hackability, and efficiency. Efficiency for me, it's for the developer, reducing the cycle of development, and also to be good in production for performance. So with microlam, you can easily create a complete project that is working that time. And it will be for AWS Lambda. You have also the CDK that will be configured immediately, and using the API gateway. API gateway, it's just declarative, so there is nothing too much in the project except for the CDK. The CDK, I told you, it's a way to write your infrastructure with code. So there is, microlam is providing one class, create app, containing all your infrastructure. In this class, you will have code to define your API. Okay? So someone don't know what is API gateway, perhaps? Everyone know what it is? Okay, good. Everything is Maven. So if you want to change something, you are free. You have everything. On the project, you have everything to change everything. So no specific plugin, no annotations. I don't like annotations. Also magic, and it's working. I'm old school for this. And it's using Docker. Okay, Docker, now it's very important. You are developing on Mac. You want to compile for Linux. You need Docker for that. If you are not compiling, you don't need Docker. And also, I'm providing small useful libraries for Lambda, DynamoDB. DynamoDB, it's a NoSQL database that is very interesting to use. For DevOps, so you have some tasks for deploying, things like that, and for the logs. And also, you have access to a simple documentation, so it's a small framework. There are 2 guides only, one for creating your first application, and the presentation will be based on it, and the second one for going deeper into the AWS service you can use. And it's 100 open source. Okay, the features. So to begin, you have to use a Maven archetype for generating your project. Okay, you remember it's a complete project that is working. It's not a part of a project. So we will see what is this project. There is support for 8 and 11. For Lambda, you can choose a standard runtime. For example, if you are targeting Java 8 or 11, AWS is providing you a standard runtime. So it's very easy, no problem. But when you want to use Java 17, AWS is not providing one. So you have to provide a custom runtime. And in this custom runtime, you will need to provide the Java runtime. You will need to provide a lot of things to make it working. Okay. So microlam is providing you what is called the Java layer. Okay, it's a Lambda layer. It's inside the AWS Lambda. You have the possibility to store a layer. A layer is just a zip that will be uncompressed and used with your files. So it's a good place to put the Java runtime here. So it's already done for you, and microlam help you use it very easily. And also, you have support for all the version of Java with native compilation, with GraalVM. Okay, GraalVM is including a tool called native image, and this is this tool that will be used for compiling. The problem with Java is that it's a dynamic language. You have reflection, you have a lot of things. Compiling is a very difficult task. So sometimes you need some configuration and to provide some configuration to GraalVM, and if not, it will not compile, or during the execution, it will throw an exception because there is one class that is missing. Okay. So this part is very important, and microlam will help you to generate automatically the configuration. GraalVM is providing a Java agent you can attach to a JVM that will record everything that is occurring in the JVM and will generate the documentation, the configuration files automatically for you. Everything is ready to use, and you can do your cycle of development. It will generate your new configuration automatically. And also we have support for the two architecture, ARM64 and MD64. This is also important for the costs, because if you are using ARM, AWS is telling you that you will pay more, less for more. And also the pricing for the memory second used is less for ARM architecture. So it's very interesting to use ARM for when you are compiling. And also you have support for the CDK with SnapStart. I have a slide on SnapStart. It's very new, so we will talk about it. And also for SAM, this is the previous way to deploy for serverless application model, something like that. So with a declarative way to deploy your architecture. So, but this is a recommended way. So this is what I will try to show you. So the problem of the cold start. So what is a cold start? This is the time taken by the Lambda to initialize your service, your JVM, start the container, JVM, load your class. And this is a time taken only for the first time. Okay, the next time it will be hot. It will not be cold, and it's just running your business code. But before, he has to do a lot of things. This is called the cold start. Here on the report, this is a report taken from CloudWatch on a real application in production. And we can see it's also an optimized application, but we can see that the init duration is more than 5 seconds. The init duration can be 10 seconds maximum. Something interesting is that when you are putting things in the init duration, it is using more CPU. So it's interesting to reduce the time of the global time of the call to put a lot in the init duration. The problem is that it's also creating this cold start problem. So for example here, you can see that the build duration is only 800 milliseconds. Even if the init duration, so you are not paying for it. The problem is that it is existing. Your customer facing the API will see this time, will not see this time. This is just for the invoice. So it's a big problem, and there are several solutions. So one solution is to optimize and tune the JVM with your code. So we had a talk at the Java.IL conference about this. So it's working fine for a lot of cases. Now we have another solution called SnapStart. We'll see it in the next slide, but it has some limitation. You can use only Java 11. You have also, when you are deploying a Lambda, you can use versioning. And if you are using SnapStart, you need to use versioning. So you cannot work with the latest version of your code. For example, when you have an endpoint in API gateway that is going to Lambda, if you are not precising a given version, it will use the last version. So it's fine in some case. But for Snapshot, you will need to go to a specific version. Okay, so this can be solved, and it is interesting to use an alias. So you can use, for example, live for the alias for the last version. And in that case, when you are uploading a new version, you need to say this version will be the new live version, and automatically it will be redirected to the new code. You cannot use also another limitation, ARM64 and X-ray. X-ray is a way to monitor your code in production. We talked about another tool, but inside the AWS world and Lambda, it's easy to use X-ray, and it's not available when you are using Snapstart. But something interesting, people at AWS found that there is a big problem of cold start for Java, and Java is the first platform where we have this optimization, and I think it's very good for us. The other possibility is to use provision concurrency on the Lambda, but it has additional costs. Provision concurrency, it's a way to initialize a lot of containers with Lambda ready. Even if there is no work, they will be ready, and when a request is coming, it will enter in on your list of provision Lambda, so it will be without any cold start. But there is an additional cost. And the last solution, compiling your code with GraalVM native image, and you said it's a difficult task. So with microlam, my target is to make it easy to do this task. So just a little more information about Snapstart. So it was announced at AWS reInvent less than 1 month. It's already supported by microlam. And so you can see here an execution without Snapstart. So you have all this code, all this part, okay? Create the execution environment, download the code, start the runtime, initialize your function code. All this part is in the init start. This is the cold start we talked before. And finally, this is where you are doing your business in your handler code inside the Lambda. And what Snapstart is doing, it is initializing the function ahead of time, and a snapshot is created here. Okay, before even we get a request. And after that, we have just to do a resume, and in a few 100 milliseconds, you are ready to run your business code. So we talked about the limitations here. There are other limitations like using EFS, a network file system. Also, you need to verify that the initialization may be reused across execution. So if you are initializing a random number generator or something like that, it's not a good place for putting it in the init when you are using Snapstart, because all your Lambda will use the same random that will not be random. So there are solutions for that. And also, you can use hook before checkpoint, after restore, to put some code so before the snapshot and after the snapshot. Okay. So, for example, if you have something that is requiring a connection that is in the init part, you can restore the connection after the snapshot, something like that. So this is important, and you have the possibility to do it. It's using Crack, which is a project, an open source project. If you have any question, well, it's okay.
Wait, Crack is a project started by Azul. Gil Tenne, the CTO, was guest in our meeting a few times. He talks a lot about the garbage collection and stuff, but this is something that was developed by Azul, and then the API was used by Amazon, by the JVM. But not by the JVM team, by the team that develops the Lambda.
Okay, so let's enter in microlam world. So everything begins with this. Okay, you should know how to use it. So you just copy paste and it will work. And afterwards, you have to answer a few questions. So group ID, artifact ID, version package, you know what it is. It's a standard properties. And this is specific. So you need to precise what is your AWS profile. So when you are configuring an account, you are creating a profile for this account. Everything is documented also in the AWS documentation inside the site, the microlam site. And so it's just a name. Okay. The region you want to use. So an AWS Lambda is specific to one region. So you need to precise which region you want to use. So to deploy in this region. The Lambda name you want to use. So for example, you need to use a name that is a legal class name. Okay, like this one, microlam demo. And an AWS bucket. So this is for S3, just where you want to put your deployment descriptor. So the build of Lambda project will generate an artifact which include all your code for running the Lambda, so like a zip. So what we get with this? Okay. This is a presentation of the initial project. So evidently, this is not exactly what you want to do, but it has a structure. It is doing something, and you can modify for your needs everything. So for API gateway, you have two endpoints, post mult and post sum. And you are sending to, for example, here it's sum, a JSON with arguments as an array of integers, 2, 4, 6, and the project will generate the answer. So it's very, very simple. Just one thing, here you have the Lambda, the micro lam demo, okay? Forget this for now, okay? And the link between API gateway and Lambda is using a proxy integration. Proxy integration, it means that it is taking your JSON input, adding it to a bigger event coming from the web with all the information about this event. For example, the HTTP method is post, okay? This is a resource. The body will contain everything you have on the input, okay? So this is the input, the real input of the Lambda, okay? This is very important. For API gateway, this is input, okay? But for Lambda, this is input. And here, this is something created by microlam. So you have only one Lambda that is deployed to AWS. But in fact, the code is modular. So you have a proxy that is redirecting the call to a real class that is also possibly a Lambda, but not deployed to the cloud. So you have only one Lambda. Okay. The first time I created this, it was to solve a little the problem of cold start, because if you have only one Lambda for all your calls, there are more chance that it will be hot and not cold. So, but finally, I found it also useful to separate your development and to keep it simple, because you have only one Lambda, and also modular, because you are putting all the handling of this call in this class, this call in this class. Okay, this is an example what you get on the microlam Lambda demo Lambda. So it is you can see here you can use the method, the HTTP method, space, and the resource, and to redirect it to the Lambda you want to use, and automatically it will do the work. So regarding AWS, using only one Lambda for all your calls is an anti-pattern, but you have several, doing like this way, it's not completely true, because it's simplifying your deployment. It's as simple as monolithic code, but it's modular. You have more chance to get your Lambda hot, and you get all your logs at the same place in CloudWatch. So it's easier to look what you are, to search for what you are looking for. Okay, how to build? Okay, simply Maven package. I couldn't do something simpler. And it will build your Lambda deployment package. So you will have in your target folder the zip with everything you need to deploy. And for the CDK, okay, you don't do anything, just CDK deploy, eventually after CDK bootstrap, if you never did it on your machine. And everything will be on the cloud. And you can define in this class, we will see the code after, in this class that is provided in the test package, you will have the possibility to modify completely your infrastructure here. Okay, it's configured in this file, it's built above CloudFormation, and also microlam is providing an end-to-end test you can use and modify for your needs that will test directly that your service is deployed correctly. Okay, for Java 17 and 19, we will need to do, by default, it is using Java.11 because there is a standard environment and it's the easiest way. But if you want to use Java 17 or 19, you have to do several things. The first thing is to modify in the POM the release version to the version you want to use. You need to bring the Java layer. So this is a zip with the Java runtime, everything you need for running your Java 17 and 19 code, okay, without compilation. And update your infrastructure to specify that it's now using this version of Java and that you want to compile. You use a Java layer. So I will do package to build the Lambda deployment package. Okay, the Lambda development package is exactly the same for Java 17 or Java.11. The structure will be exactly the same. And this is possible because of the use of the Lambda layer. Here, I'm adding one property for bringing the Java layer. So I'm precising Java 17 layer and the architecture. Okay. When it is a custom runtime, you need to choose if you want to choose a custom runtime based on ARM64 or AMD64. And then CDK deploy. Very easy, 3 steps. And you have your Java code, Java 17, 19, working in the cloud. But with the cold start problem for now. With the version Java.11, snapstart is already activated. So it's solving, in a way, partly, almost completely, the cold start problem. So now the difficult part, to compile with GraalVM. So you remember you need Docker for that. You will use exactly the same command, okay, till here. Package. Now the property is native, equal the platform you want. So Java 17, 19, 11, and also the architecture. For example, AMD64. And here you decide what you want. Config will not build anything, not compile anything. It will just build an environment to generate the configuration. It's automatic. So you put config, you have local Lambda that is answering your local calls and generating, using this this calls your configuration for the compilation. The second one for really compiling. So the configuration should be in the class path. We will see the structure in a few slides of the project. And compile, just will compile your project and generate a new artifact containing what you need to deploy for running your custom runtime. The run is for running your compilation. So you are not, it's not necessary to deploy to the cloud to test what you have compiled. So there are several ways to compile. There are ways where you allow fallback. And in that case, the compilation will work fine. But finally, when it will encounter something and missing one class, it will crash. So it's good to try your run before and to win time for your developer efficiency. So you can do this with this command. So it's exactly the same, just add the profile run. It's available for all the Java version, all the architecture. Again, you are modifying here. There are 3 lines to modify to specify that you want to use the compilation version. We'll see it. CDK deploy to deploy it. You have the possibility to test your local environment. You run locally, for example, with local Lambda tests. And when you have deployed completely to the cloud, you can use the end-to-end test. Okay. You have also, evidently, unit tests to test your Lambda without doing anything. Evidently, it's also in the default project. So let's try. So for the demo is very ambitious. I want to compare the performance and the cost for running Java 11 with Snapstart, okay? For running Java 17 with a Lambda layer, okay? So it's also a custom runtime, but it will be without compilation, but it's a better version of Java, let's say. And finally, Java 19 with GraphVM native compilation, okay? If someone is reading this and had already tried it, he should think I'm crazy because it's looking impossible. But let's try to do it. I hope the internet is enough good. So let's begin. Okay, with the archetype. Okay, the first line. So we are creating the project. I choose a big font so you can follow what's happening. Okay, so I press 2 times to enter. So, okay, the first question is a Lambda name. Okay, let's begin with the default project with Java 11. Okay, we will call it for our Lambda microlam demo. The profile is microlam. Microlam is on my machine. I'm using always European region. The bucket microlam deploy. Okay. Group ID, let's take something different from microlam. I will take the group of my company. And the artifact ID will be microlam demo. Okay, I accept the version, the package. Okay, that's finished. Okay, now, okay, here what we want to do is to package my Lambda, so Maven package. So it's compiling. Okay. Okay, that's all. So we have here the target. Inside the target, you see the file with the suffix AWS Lambda. So it's standard Lambda package. You can deploy this. And to deploy this, I will start the CDK deploy. I will not wait for it to finish, but we can see the beginning eventually. And I will do in parallel the work for the other project. Okay. So here, let's take the same archetype. So now the second one is the Java 17 with the Lambda layer. Okay. We will call it microlam Java 17 demo. Profile the same. Region. And the same bucket. The same group ID, and artifact ID will be microlam Java 17 demo. Okay. Perfect. Okay. Maven package. It's useful because it's exactly the same package. If you are, oh, I forgot something. Okay. Someone come tell me what it is. I forgot to change the default version of Java in the POM. So I will go to Eclipse. Okay, import my project. Okay, let's import this one for now. This is the one I need to modify. So here you can see the files. I will present you the files in another slide. Okay, the Lambda is here, microlam 17 demo. Okay, you remember, I showed you before. And so what we need to change is release version in the POM. This is a place, okay, don't forget. If you want to use Java 17, you need to do this. Okay. In Eclipse, to be sure to see it, you can update the project. Oh, it's already done. Java 17. You see on the as the GRE. And also, there is another thing to change. Inside the create app, you remember the class that is used by the CDK. So here, we have 3 lines we need to modify here. So, is it Java or native compilation? True is for Java. Here it's for the version, so I will put 7. Okay. The architecture, I will keep this one for now. And that's all. So now I can come back to my demo. Here I will clean it. So everything will work correctly. And it will be compiled with Java 17. Okay, so now you can see the file here. This is the deployment package with the suffix AWS Lambda. It's a zip. Okay. Now we need to bring the Java layer. So the command is very simple. You can do copy paste Java 17 layer equal the architecture AMD64, and that's all. Okay, and what you see here, Lambda Java 17 layer with this, and you can verify it's a good architecture. So you have your files are here now. You have the layer and you have the package. You can deploy. CDK. Deploy. Okay, so let's see if the first one has finished. Okay, it's finished. It's deployed in the cloud. Okay, the second one is starting. And now I need to create the third one. Okay. Looking for the archetype. Okay. It's here. So now we want to use Java 19. Okay. It's the more difficult one. We want to be able to compile to native and to deploy this to the cloud. So here, microlam Java 19 demo. Okay, profile, you know it now. Region the same. Okay, the bucket microlam deploy. Okay, the group ID. Okay. So now, what we need to do, change the files. Okay. So I will import the project. Okay. So this is this one. So we have two files to change. The POM. Now we want to use Java 19. And second things, the create app file for the CDK in the CDK package. And now, on the 3 lines, we will say Java, no, false. It's native. And here, 19. Okay, I will keep AMD64. It's called by AWS x86-64, the same. But my Mac is I'm using now is based on Intel chip, so it will be faster if we can do it to compile with it. So let's go to the project. Now, what we need to do, we need to build the default package. And now do the compilation. Now the command, okay, so native, the Java version you want to use, Java 19, and the architecture, AMD64. And the profile to precise what you want to do. For now, the project is already configured, so I will take a shortcut. Instead of config, I will use compile directly. That's all. Okay, now you can verify. So it is using Docker. You have on the project the Docker files. You can modify them. You can do what you want with the project. I will show you for Java 17, it's deployed to the cloud. Okay, so we are waiting. Oh, there is a problem. Okay, I know what. Now, let's see. Okay. I know why. So I will just clean before, because I did a package. Okay. Okay. So can give him the time to complete. So it's generating the native func and executable. It's using the last version of GraalVM. You see, this is Java 19. Okay, this is the architecture we choose. Okay, everything is working. So let's give him some time, and we'll see what we have on the initial project So this is all the files for the main Java. So you have all these classes that are dealing with the Lambda code. So we say that it was microlam demo, okay, the name of the Lambda. So the Lambda is here, redirecting to this one and this one. We'll see after the real code. These two classes are just a way to bind the JSON to Peugeot class, okay, Peugeot Java. And this is your business. So it's just adding and doing a mult. It's very easy. Okay, this is important for the compilation. You have already the configuration for this project with these two files. So it's JSON files you need to provide, and they're already provided. You can modify them. Okay, reflect config and resource config. This is for reflection, and this is for saying which resource to use. For example, in this code, I have this simple logger properties that is used for configuring your logging. And if you want it to be taken into account during the compilation, you need to say, oh, I want to use this file. Because he is looking for your classes. This class is depending on this class, so I will include also this class. But a resource, it's more difficult for him. So, what? 5 minutes? Okay. Should be okay. Okay. So this is a part for the tests. Okay, we talked about the end-to-end test. AWS, this is for configuring your AWS environment in your test. You put AWS configure. It will use your profile and your region automatically, the one you configured from the prompt on the create project. The create app, you know it now. You have also two classes that can be useful for deploying manually, okay, without the CDK. And here, just a few files for end-to-end test and direct test. Okay. I'm going fast. Okay. This is what you did not see really, but in use in the Docker files one for compile, config, run. Okay, it's logical. So you know where to look for if there is a problem or something. And here you have the bootstrap. Okay, for the custom environment, you need to have a bootstrap file. etc. If you want to modify it, it will be used. The CDK is configured here. These three files are for SAM. Okay, it's now not recommended to use it, but if you want, it will work also with SAM. It's a command line you can install, and you have a README with all the commands you can use. So you see, it's not difficult, but so I'm curious to see. Okay, the compilation has finished. So now let's see in the target folder which zip we have. Okay, so now you see the file here. Okay, that's better here. AWS Lambda native. This is a suffix for the native package. So that time it worked. Okay, so let's go. Let's do a CDK deploy in the meantime. Okay, and now we can see that the deployment for Java 17 has worked. For Java 11 has worked. Okay, let's see in the slides. Have not a lot of time, and okay, before I will show you without a lot of time. It's difficult. Okay, so let's go. I don't know if I have some time. Okay, not good. I forgot to do the initialization before. Okay. This is, you should cut it on the video. Okay. So now let's go to, this is the AWS Console for people not knowing. So you go to Lambda, and here we can see our three Lambda functions we deployed. Okay. In fact, you can find in applications, you can find the three applications. Okay. So we can see that the third one has worked also. And on the layers, you can see the Java layer we use to deploy. Okay, the AMD64. Okay, let's do something very fast. Okay, I need to import the project that is missing. This is the simplest one. This one. Okay, and now what I will do, it's very fast. Take the end-to-end test. Okay, let's begin with 17, and I'm running it. Okay, from Eclipse. Okay. Automatically, he knows exactly which application to test. Okay, because it's inside the initial project. Everything is configured for this project. So this is end-to-end test for the microlam Java 17 demo. Now I will do the same for the, okay, let's do it another time to have more execution. In the meantime, I'm doing the same with, in parallel for the demo because we are missing some time. Okay. And in parallel with the third one, where is my class here? End-to-end test for the native part. Okay, let's go to the cloud, to the console. We will go to CloudWatch. This is where we will find the logs. Okay, so we have a log group for each one of them that has been created. For example, let's begin with this one. Okay, and here we can see, okay, the first execution. You see the beginning, restore report, okay, because it's using a snap start. Okay, so there is a time. The time for restoring was 200 milliseconds. Not bad at all. It's very good. And the report time is here. So, approximately 2 seconds. Okay, including all the time for the first, the call start. Okay. And for the second call, it's impressive. Just 29 milliseconds. This is because we are using, it's already hot. But the difference between this and this is not so big. So it's very interesting. And the performance, you see the performance of Java when it's hot, it's very good. So now let's see the logs for Java 17. So it was with the Lambda layer. The time, okay, it's now out of time. Okay, so believe me, okay, I will show the results. Okay, I will show you the results. Okay, this is the results. So we can see approximately this is what we found for the Java 11 with snap start. So the first, the call start is 2 seconds, so something like that. With Java 17, it's not bad at all for the call start. But the problem is that the init duration is only 789 milliseconds. But in a real project, it will be 5 seconds, something like that, as I showed you before. And so for this example, it's not a problem. But for a real case, you will see a problem on Java 17. And with Java 19, Okay, the good surprise is it's only 326 milliseconds for running it in the cold start. And this is unbelievable, 4 milliseconds. And you are paying only for the millisecond. This is the build duration, 4 milliseconds. So it's impressive, and I think it's interesting to use a project like this to be able to get these results for your applications. Okay, what's next? You have documentation on the microlam.io site. You can see also a very interesting library for DynamoDB. And the project is very young. If you want to contribute to even to test only or to contribute to the project, you are welcome. And that's all. Thank you.